Hello, welcome to the Unit 7 video on Day 6 notes, which is solving power equations, where the variable's in the base and we're using reciprocal powers to solve. This is going to be a pretty quick video, just talking through a few of the examples so that you get an idea of how to fill out the rest of the notes and ultimately what we're doing. So in order to do these problems, the first thing is to always make sure you isolate the term that has the exponent or radical on one side of the equation, and then we'll raise both sides of the equation to the reciprocal power. Now, if the reciprocal power has an even number in the denominator, we'll end up with two solutions, so don't forget the plus or minus. And then we will check our answers in the original equation by substituting and separately calculating on each side of the equality. Keep in mind that solutions may not satisfy the original equation, and those are called extraneous solutions. So talking through this example that we have typed in our notes, this is what we call a power equation, where the exponent is 4/3, so it's a fraction. So what we end up doing is raising both sides to the reciprocal, which would be 3/4, because by doing that, we know a power raised to a power creates an exponent of 1. So those undo each other. But whatever I do to one side, I got to do to the other side. So that's why you're seeing a 3/4 on the other side of the equation. Now, because the denominator is even, you're going to end up with two solutions, so don't forget the plus or minus sign, which you're seeing here. So these undo each other, so that leaves you with x plus 2 to the first, which is just x plus 2. Rewriting this with power over root, this is the same thing as the 4th root of 16 cubed, which is the same thing as 2 cubed, which is 8, which is why you're seeing plus or minus 8 here. So then if I subtract the 2 over, I have -2 plus or minus 8. So -2 plus 8 would give me a 6. -2 minus 8 gives me a -10. Now, you could do an algebraic check by plugging in both the 6 and the -10 and seeing if it works. Or you can do a graphic check by plugging the left side of the equation in for y1 and the right side of the equation in for y2. So that's what I have here. If I hit graph, you'll see this is x plus 2 to the 4/3. Here comes y equals 16. Oops, I shouldn't say that. My window's wrong. Hold on a second. Make a y max of 20. I'm not going to see y equals 16 on a standard window. All right, so x plus 2 to the 4/3. Here comes y equals 16. So I should then end up seeing intersections at -10 and 6. And I do, and I can confirm that in my table. If I go to -10, there's your repeated y value. Go to 6, there's my repeated y value. So that's the idea here, guys, okay? So biggest mistake students will make with this is they just simply won't isolate the thing that they need to isolate to be able to solve. So what I mean by that is something like number 4, let's say. They just start raising things to the 5/4 power. You need to isolate first. So what I'm going to do is divide by 2. And then I raise both sides to the reciprocal power. So this would be 5/4. This would be 5/4. Now, because the denominator is even, you're going to get two solutions. These undo each other. So this is m minus 2 equals plus or minus the 4th root of 16 to the 5th. Okay, now the 4th root of 16 is 2. 2 to the 5th is 5. So that's how we get 32 from that. So plus or minus 32. Add the 2 over, and we get 34 and -30. Now I'll save the check right here, guys. Both of those would work, but that's how you would do that problem. All right, take a look at something like number 5. Okay, I divide by 3. I got to isolate the thing with the exponent. This is b to the -2/3 equals 9. And then I raise both sides to the -3/2. These undo each other to create a b to the first. And don't forget the plus or minus because the denominator is even. So this is plus or minus 1 over 9 to the positive 3/2. And then I can rewrite that using power over root. So square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. And that's how we end up with plus or minus 1 over 27. All right, let's go to the next page. All right, look at something like this guy, number 8. Okay, I gotta get that a to the negative 1/6 alone. First thing we do is subtract the 3. Then I'll divide by 4. Now, 2 divided by 4 is the same thing as 1/2. Ooh, excuse me. So then we'll raise both sides to the reciprocal power, which would be, whoops, where'd my thing go? Nope, not that. Which would be negative 6 over 1. Or negative 6, however you want to write it. Now keep in mind here that the denominator is odd, so you're not going to get a plus or minus in your solution. So I have a equals, I just kind of rearranged it, a equals 1/2 to the negative 6. Now whenever you have a fraction raised to a negative exponent, you can flip the base. Now the exponent's positive. And if 2 to the 5th is 32, times 2 again would be 64. Now let's see, does that make sense? If I pull up my calculator, which I have here, okay, and I go to the original, I have 64, store it as x, and then I can type in 3 plus 4x to the negative 1/6. Let's see what happens. Oops, forgot my 1. No, not negative 16. There we go. And I get 5, which is what I'd hope it would do, and that checks. Now, keep in mind that every single one of these fractional exponents is the same thing as a radical. So like when you're solving something like number 10, if you want, you can think about this as, oops, not the highlighter. You can think about this as 22 plus c plus 2 to the 1/7 equals 21. So subtract the 22, you get c plus 2 to the 1/7 equals negative 1, and then you're raising both sides to the 7th power. And so on and so forth, and then you'd solve from there, okay? Which is the same idea. Just like how you guys know how to undo a square root by squaring both sides, you're undoing a 7th root by raising to the 7th power. It's all because of reciprocal powers. All right, the last one I'll leave you with here is number 12. Again, I got to first divide by 2. So this is 3a plus 2 to the negative 5/2 equals, now times 1/2 is the same thing as divide by 2, so this is 1 over 32. Now I raise both sides to the reciprocal power of negative 2/5. Now because the denominator is odd, not even, I don't have to worry about the plus or minus. So this is 3a plus 2 equals, I'm going to flip this base, and now it's a positive exponent of 2/5, which is the same thing as the 5th root of 32 squared. Now I know the 5th root of 32 is 2, and 2 squared is 4, so 3a equals 2, so a equals 2/3. Now let's see, does that make sense? If I take 2/3 and store that as x, I'm going to type in 2 times 3x plus 2 raised to the negative 5/2. See what that is as a fraction. It's 1 over 16, and it checks. And that is how you solve power equations with fractional exponents.